My name is Chris Clark, and I'm here with Townsend Harris, and we're here to talk about attacking WebOS. To give you a little bit of background on both of us, Townsend Harris here is an independent researcher who did a lot of the WebOS research as a hobby when he was holed up in a hotel room. I did it also as a hobby. I work at ISEC Partners. I do application security consulting. But I did it when we had to write a mobile application security book, and we needed 50 pages at the last minute, so I had to figure out what else there was to write about. So we decided to go after WebOS. The agenda today, we're going to introduce WebOS. I don't think it's really been talked about at many security conferences, or really just much in general. So we're going to give an introduction into WebOS and the major operating system components, and talk a little bit about how they interact. Of course, it's a security conference. We want to talk about finding bugs. So we'll talk about some of the techniques that we use to find bugs, what it even means to have a bug on WebOS. We'll talk about injection flaws. If the name web didn't tip you off, maybe there could be some web-like injection flaws in WebOS. And then lastly, we'll talk about local attacks. And these are ways to escalate privilege if you're either a malicious app running on the system or you've found a way to compromise a legitimate app, but you want to get access to the user's data. So a little bit of background about WebOS. It is basically a Linux distribution, a specialized Linux distribution that runs on specialized hardware like the Palm Pre. This was the first phone. It was released on Sprint about a year ago, last June. There's a second version of this phone called the Palm Pre Plus. It's on Verizon, has a little bit more RAM, a little bit more memory. And then there's the Palm Pixie, which is the same phone in a different form factor. Like many embedded devices, it runs the Cortex A8 ARM processor, and it's a pretty neat phone. As far as WebOS architecture, this is the way that I think about it. Maybe some system architect at Palm would disagree. But the basis, there's the Linux kernel. And on top of the Linux kernel, you have various processes running. And the way that those processes are connected is via Debian dbus. There are two dbuses. If you're not familiar with dbus, it's an IPC mechanism. So the services sit and they listen for messages that are passed between applications. There's a private dbus and a public dbus. The private dbus is for sensitive applications like the email store or maybe the messaging store. The public dbus is where a lot of the system services that are accessible to the public API live. And so there's certain rules about which applications can talk to which bus. There are system services that are running. These are either Java, C, or C++ running Linux processes. And they might support long-running functionality that you need in the phone, like the system that's going to pull the email server every few minutes to download email, or something that's going to monitor the radio for SMS messages, parse those messages, download MMS content. But the real heart of WebOS is the Luna process right here. All of the native WebOS applications run within Luna. It's one process on the operating system, and then Google's V8 JavaScript engine is used as the backing JavaScript engine. So Luna, what is Luna? It's basically a specialized web browser. It's based on WebKit, and everything that you see on the phone screen, my phone ran out of batteries, but everything you see on the phone screen is running within Luna. In fact, all the different WebOS applications can be thought of kind of like different tabs in your browser. So they all run within the same browser process, normally when you run Firefox. Same thing is happening with WebOS applications running in Luna. Supports HTML5 and JavaScript. Something that's really interesting is that the way that you can get access to some of the device's hardware is via specialized NP API plugins. So I don't know, maybe you're familiar with Internet Explorer. You have ActiveX controls that let you bridge to native code. NP API plugins are the way that Luna can bridge to native code like the camera. The actual process is the Luna Sys Manager process. And like I said, all the WebOS applications run inside Luna Sys Manager. Now, a WebOS application, as far as a native application, is basically just a big bundle of JavaScript, HTML, and CSS. These are packaged up and they're specialized JavaScript functions that allow the device to interface with other system services. And that whole ball of wax is known as the Mojo framework. Okay? Applications use HTML and CSS. If you want like a specialized button, that's just a specialized tag in HTML, or maybe it's a specialized CSS class. I forget exactly, but the point being that specialized HTML and CSS use JavaScript. WebOS applications are not exactly like web pages. Obviously, they're not bound by the same origin policy. So I can create an application that can access Twitter and that can access Gmail. The web browser or Luna doesn't enforce that restriction. But I'm not supposed to be able to have access to files. I actually, much like a web application, store file data using either a cookie object or using HTML5 depot backing database. And one kind of funny thing to note is that the web browser object or web browser application is actually a separate instance of WebKit. So you have WebKit that runs inside WebKit, and that is bound by the same origin policy. That doesn't have access to things like the camera control. That is its own set of controls. So if you're going to run Flash, you can't use Flash within Luna to write applications, but you can use Flash within the specialized web browser. So there's actually two web browsers on there with different sets of restrictions. Every application has a namespace, and the namespace is an important way that the security system is triggered. So it's reverse DNS notation, like Java apps. So com.pom.apps.messaging is the messaging application. I mentioned there are system services. They're accessible by dbus. Everything has a URL. So pom/com.pom.mail. They can be written in C, Java, and JavaScript. And by convention, everything talks JSON, even the C services and the Java services. Many subsystems, like the email subsystem, will have a public interface and a private interface. And that's because you don't want every app to be able to read all of your email, right? I don't want my Solitaire app to be able to read all of my email. So I keep the actual access to the email store on the private bus, but I provide like an email service that lets you mock up emails on the public bus. Some services are private bus exclusive, like that email store I just mentioned. So example, like I just talked about mail, the public service. Hopefully I can step away from the mic, you guys can hear me, I'm loud. Anyway, the private service is hosted at com.pom.mail, and this is actually how you would get access to an individual message. The public API that third-party applications can use are prohibited from accessing this because it's on the private bus. They can only access the mail service through the mail-to URI handler, and this is how you pop up a mail where the subject line is filled in, the to lines filled in, and I don't know, I forget if you can fill in the body, but whatever. As far as launching individual documents, there's a global registry of URL and document handlers, just like you find in the web registry. And these are all publicly documented, but you can launch documents, PDFs, media files. Most URL launching actions, if done from the web browser, will download the file and then require you to actually click on it to play it. So hopefully you can't just download a doc and have it open. That would be a bug. There are many more application handlers or URI handlers that you can access from the web browser. And if our experience on basically every other operating system has ever taught us anything, that every time you have a URI handler, you have an attack surface that probably hasn't been totally reviewed until it's been patched 3 or 4 times. So all of these are open up so that Yelp could write an app. It's running in the web browser. You can click a button that says show me the directions, and it will use the map to or the map location URI to open up the mapping application. Now I'm bringing this up because most of these have actually been reviewed and hardened against untrusted data, right? Like if I launch these from a web browser, it should go safely. But if you do maybe closer review of some of these, you can see that they might have some HTML parsing difficulties, and I suggest it to be an area of further review in the future. Also, an interesting thing is almost all the URI handlers are accessible via dbus calls if you're running an application. And many of them will accept parameters that are either undocumented or hidden in Palm's documentation. You can see them by reading the source code. And I can guarantee you that many of those are not validated. So I suggest reviewing those in the future. Now, everybody, when a new phone comes out, the race is like, how do we hack it? How do we get root? Well, for the Contra and Konami fans out there, Palm has made it really easy. You enter the Konami code, up, down, left, right, BA, start. If you actually, you have a friend over, it's BA, select start. You get 30 lives, and you're good to go. Once you've entered this code and enabled developer mode, you can plug in a USB cable, and you can get root access to the phone using freely downloadable utilities from Palm. One thing to note is if you have a device pin, you enable developer mode, then the pin will still ask you for it, but plug in a USB cable and your device is owned. This isn't really a security thing. I think it's just really cool that you can enter the Konami code and get complete access to the phone. Okay, so that's a background on WebOS architecture. And without further ado, I'd like to turn it over to Townsend, and we can talk about how we approach finding bugs and some of the bugs that we found.
So, hello. As you can tell, Chris has done a lot of architectural analysis, and he'll actually go into some interesting bugs he found through that architectural analysis. I'm going to try and drive you through some of the stuff that we did to try to find some bugs, because that's what we do. So before starting down this path of trying to find bugs, we have to talk about attack surface. So what is the attack surface? Well, pretty much the attack surface for this phone is almost everything your desktop can do. And just like your desktop now, it's going to be wired 24/7. So we have a lot of things that we can attack in this particular phone. So we have email, SMS, various media player capabilities, instant messaging, file viewers, that kind of stuff. So what people target nowadays as basic things to go after or targets, you can do the same thing in this phone. And almost all of the things you can do on your desktop, you can do here. The only thing we have here now is we have some SMS as well. The one thing I always like to point out is go on to the days where a phone was just a phone. Now a phone is your web browser. Now a phone is your music MP3 player. So it's really interesting how this is all panning out. The other thing we wanted to sit back and take a look at was what are the goals? So goals are always, for most bugs, I want memory corruption, right? That's sexy. That's what people want. I want remote root compromise. You don't always need memory corruption to get remote access. You can do some things, and we'll talk about later. We can do some neat injection attacks later that can give us access to the phone, the things that we want on the phone. So one of the things we sat down with was, effectively, since this is a hobby, and we're doing this part-time, memory corruption we knew would probably take a little bit longer. And the HTML injection is something new because we have both the binary side, and now we've got some interesting WebOS stuff on top of that. So you'll see us kind of talk about everything we wanted, but we sat down and the real goal was to get data. Since the phone itself is not amazing in storage and probably won't have amazing bandwidth, we're not worried about that side of it. So we would want to know, say, hey, listen, I target someone in the room, can I get all of your email? Can I get access to all your email or SMS? That kind of stuff. So that's kind of where we went with it. So this is a nice list. One thing this list shows is in a year, this is how many patches Palm has gone through. Most of this is probably because of us, but it has a lot to do with a lot of other updates that they have performed. The good thing is that they're very responsive. So I think Chris will attest to this as well, is we would release something and they'd be all over it. We have had time and time in with the head of Palm Security, and they have been nothing but wonderful for us. So it was really cool. But this is just a nice list showing how often they patched and kind of the bugs that we found and submitted to them. So I guess everyone wants to know is how do we test this thing? So the first thing we did is we looked at the attack surface, and the primary thing was, all right, what do we hit? What do we go after? What's the big exposed interface to the internet? Well, like everybody else, we went after web browsers, email, SMS, the media player, and even and file formats, because file formats are a pretty big target these days. So how do we do that? So we started with source diffing. All of these devices, they baseline upon release, and they say we're using this version and this version of code at this point in time. Well, what's nice is that Palm made this phone so open that it utilized. They have what's called the Palm open source portal, where they give you the list of every piece of software that they use that's open source, and they give you every list of changes that they've made to that software. So if something was to come out, say tomorrow, WebKit gets owned, well, what version of WebKit is the phone using? Let's go back into a source diff. And this makes it very easy to go through all the code. Fuzzing. We fuzzed. We did a lot of fuzzing. We wrote some proprietary fuzzers. We utilized WebOS technology to fuzz itself, and we'll get into that in a few minutes. The other cool thing is that we talked about the source diff. So we have open source code, but this is all HTML, JavaScript, and CSS, and they don't obfuscate any of it. So if you wanted to see how it works, run the Konami code that Chris talked about earlier, log into the box, and check out all the code yourself. A lot of the analysis that was done on the architecture and even some bugs we found were based on the source code analysis. So source diffing, this is pretty simple. WebKit gets owned today. Does the Palm Pre WebOS suffer from the same bug? Go get the source, go find out. It's pretty much that simple. The open source, Palm's open source site is really nice in that it gives you that listing of all the open source software as well as the individual patches that were made. So it makes it very easy to go through and do the analysis. One thing we wanted to point out is this is not just a problem for this phone. This is a problem for, say, other phones and other embedded devices that have like long patch cycles or have to go through large amounts of quality assurance testing before patches can be released and that kind of stuff. So while it does affect WebOS, it's not just WebOS. So the way this started was me in a hotel room with a buddy having a beer. Like Chris said, I was doing this initially in a hotel room on travel from my previous job. And I was bored. And I was like, well, let me look at the phone because I just got it 5 days ago. So I generated a bunch of wide range of URL values, emailed them to myself because I didn't have a USB cable. I didn't have anything, any tools ready. And I did some really cool high-tech stuff called finger on screen testing. And I literally would do a binary search and click on a few links here and there. And literally within the first 3 minutes of this thing, the whole phone died. So, and this is actually a quick snapshot of, this is actually, so the phone also comes, one of the hardest problems about embedded devices and phones and getting access and debugging is that you usually don't have a debugger. GDB's here, 6.8, came natively, we don't have to install anything, it's already there for us to play with. So what's nice is this is actually a core file from this, clicking on this causes this core file. So obviously there's probably bigger problems. So now it's time to go back to the lab and start running some structured testing. So fuzzing round 2. One of the things I wanted to talk about is there's an open community for WebOS, and they're called WebOS internals. And they're a really cool bunch of guys in that they are just trying to make the application, write applications, make it better, make it the whole WebOS a community effort and that kind of stuff because Palm is very open about it. So what they did is they were nice enough to host all of the optware feeds, which would allow you to download pretty much anything on the phone you want. So apt-get, we're probably all familiar with Debian, and you just apt-get install, it's really iPackage-opt, but you would just be able to install whatever you want. So what we took the approach was, well, if I have the device, and I've got access through a shell to the device, say I just install SSH, why don't I just let the device fuzz? So we ended up writing some scripts that ended up fuzzing the device itself. We would just launch applications and monitor for core files. The beauty of Luna, that Chris had mentioned earlier, is that we can use Luna to fuzz Luna, right? So Luna has the cool ability such that Chris had talked about the application manager and how if you give it, say, a file, it'll take the extension or the file association and then launch the appropriate app. Well, that's great for us because I don't have to write a web server to bang off of. I don't have to do anything crazy. All I do is have to mutate the file if that's my choice. Run it through here, fuzz it, see if it died. If it died, catch the core, see what the core says, rinse and repeat. And now I've got this self-sustained phone that I can walk around with during the day and have it fuzz as it goes. So I don't even have to do anything crazy.
Yeah, the nice thing is that with Python or whatever installed on the device and the ability to launch the process, see if it's still running, check for core, like that's normally very difficult to do on an embedded device. And so here it's very straightforward testing. And so we were able to do, like the hardest part about testing is making your fuzzer reliable so that either it crashes or it hangs or whatever. Normally it's a pain in the butt for mobile fuzzing. But here, we can run several thousand iterations using Python on the device.
Right. And you could literally just be going for a jog and it's fuzzing itself. And then you come back from your jog and you go, hey, how many core files did I get? You know, and you saw in the beginning, like Chris said, finger on screen was the first test. That's typically what you have to do for a lot of stuff if you can't get to the back end. So Palm.
You guys ran it on the physical phone itself rather than the VirtualBox emulator?
Yeah. Python on the phone.
Okay, so your phone was just like sitting on the table, just crunching away.
I kid you not. Like you just go out to get a drink or something, you know, food or something, and come back and you just check your core file, log back in your box. It's great. Although the emulator was definitely handy. The emulator was we found some nice things with the emulator too, because you can do some things with the emulator you can't do with the actual phone. So we talked about results. We found a bunch of stuff. So we can walk through some of these. So you saw the URL handling crash where I literally would click something and it would crash. Well, we found like 3 or 4 of those. Some floating point exceptions in the browsers. If it was in portrait mode, you could get it to crash. We had one bug. So Palm fixed the URL handling crash, and then within 24 hours, I had 2 more memory corruptions because they still couldn't parse URLs right. So we ended up going back to them and being like, listen, you fixed it for this length, but you missed this and this because you parsed wrong. And then they ended up fixing that again. So we did find some interesting stuff. A new thing that was found was the doc viewer crash. One thing you'll note here is this is a pretty cool crash in the sense that those are R41s, so you can kind of see how memory corruption and remote exploitation is possible. That really drives us right into the next thing. So now that we have crashes and we have bugs, we had set out a goal initially is to figure out the device, figure out how it works, find as many bugs along the way, get it patched, because if this was going to be my personal phone, I want things patched. I don't want to spend 6 months trying to figure out root cause on something specific and then find out I can't do that because NX is handled differently or something like that. So we really thought that there was another way to go with this, and it turns out with a lot of the injection capabilities of web application testing, that was really the way to go to make this much easier. So we don't need memory corruption to steal things off your phone. We can do that through some other very interesting ways. And that's what we're going to roll right into is the injection. So it's cool we found memory corruption. We can probably make a crash. We could probably have kept going with our test results and found a whole bunch of other crashes. But we wanted to really investigate the web application side of this phone. And that's where we get into some of the injection stuff. So as Chris kind of talked about the architecture, Mojo applications are all JavaScript, HTML, and CSS. JavaScript can access different phone features through the dbus and doing various other things on certain privileges and that kind of stuff. So how do we, if it's JavaScript and it's HTML, how do we inject things? Well, obviously, we're hoping for places where they don't sanitize user-supplied input, right? So how do we do that? Well, we just basically would take a test string. Something that I like to do is, this is probably something you learned in your Web 101 class, how to do a meta refresh tag. This has pretty much taken out 6 or 7 bugs of Palm. This pretty much, using this string, we were really able to find like a bunch of bugs, and that shouldn't happen. So some of the injection vulnerabilities that we found, we'll talk about the contact list. The contact list was very interesting, such that if you were to take a vCard and it had HTML in it, it would then, if you viewed the contact or someone called you or whatever, it would execute HTML. And the question is, well, how terrible is that? What is the real consequence of executing HTML? In a lot of these, you couldn't execute JavaScript, but you could only execute HTML. Well, I can make your phone do a lot of funny things. So the application manager allows me to launch a movie player, or I can redirect you to a malicious website, or I can redirect you to a malicious website that has a vulnerability in, say like loads a doc file, and I know that doc file is malicious and can execute code. So there's a lot of things that we can do with the HTML injection. We'll get into another bug later that is JavaScript injection that is much more devastating, but these are pretty important. So the contact list was you download a vCard through Synergy, which is their way of like organizing all of your contact information, so you don't have 10,000. Your dad's phone, your dad's voicemail, your dad's this, your dad's that. It would collapse everything and organize it into one contact. So they have Synergy. The calendar application, which we'll get into, our big bug is probably in the SMS or is in email. There's a couple things recent on SMS. Chris found a really cool bug in the updater. And the biggest problem outside of the email bugs are the notifications system. The notification system in this phone does not require user interaction. You receive an email, it has injection, it's executed. You got notified. There's nothing you can do to stop it. So this is a quick chart on the calendar and the email. So the calendar one is pretty simple. If you were to view the event, if someone, say you're at work, and somebody says, hey, listen, we got to get together and have a meeting. All right, well, they would send an email out and you get a meeting notice. Upon receiving the meeting notice, you would just have random execution of our HTML. In this case, we're using meta refresh tag, which would just spawn another card with Google link. If you were to get, say you had reminders set, so every 15 minutes before your meeting, you say, tell me, remind me, upon receiving the reminder notification, it's arbitrary execution of HTML. And then I talked about the notification system. So the email thing, we didn't break up the email and the calendar into their separate ones because it's kind of the same bug. It kind of fall from the same tree. If you were to receive an email where the to field had HTML in it, upon receiving that email without even looking at it, the notification would trigger and execute arbitrary HTML. So now you have all these different attacks that you could do with this thing.
Without user interaction.
Right, and the key there is a lot of this is without any user interaction. Like, before they fixed it, you couldn't stop it. One of the cool things is I used to mess with my boss by randomly send him stuff like at 3 in the morning, and he'd come in and be like, hey, I didn't go to that website. So it's kind of some fun things you could do, too. This is probably the biggest bug that we have. So this is the remote file access vulnerability that we disclosed. This was found, I think, 3 days before DEF CON last year. And I think it took a month or so to patch. What this bug is that we did some fuzzing with some JavaScript and HTML and so on stuff. And you had to watch it. It was very hard to fuzz automatically. But we did find that you could inject JavaScript. Okay, so the email systems is kind of privileged. So if I can inject JavaScript, what can I do while inside a privileged application? Well, it turns out we're not supposed to be able to access the backend system. It's supposed to be sandboxed in the backend system. So I shouldn't be able to get access to files. Well, there's a nice file URL handler that we can use. And the file URL handler is only allowed to be used in the privileged mode of privileged application. So what we do is we generate some JavaScript and basically go to this file, store the contents, and we steal anything off your phone we want. What's nice about this is Palm has stored everything in a single database. So all of your text messages, all of your contact lists, all of your emails, they're in a single SQLite database, single file.
Sorry to interrupt. Let me make sure we get everything the same on the video thing. You can use the microphone for that.
Sorry about that.
Oh, I didn't know that.
Yeah, you can pick it up and turn it around if you want.
Okay, I wander. I'm sorry.
Whatever works for you.
Well, I think we should show the demo.
Yeah, we'll show the demo now.
Yeah.
Hold on, let me step.
This is a video that Townsend made to do this. So
Hit up alone. Scroll up because your screen's too small. We can't see it all.
there we go.
All right, so I'll try and talk a little bit louder to this over here. So basically, this is my exploit. This is the emulator.
I think just
Why don't I do that? This is the emulator right here. This is a cookie catching website, which is basically I'm going to steal a file, throw it back to my website, and then I'll get an email upon receiving it. And this is just going to send me the malicious payload. So all this is, and what's going to be cool is when you see it show up here, you're not going to see anything wrong with the email. It's going to look like a normal email. I apologize for the kiosk thing. This was not meant. Palm didn't believe me that this could happen, so I made this. So here's an email that received from me, the malicious guy. All you're going to do is have to click on it, and then I'm going to steal the files right off your phone. That's pretty much. What's cool here is you don't see anything. The only interaction is that you just have to click on it. You don't see the JavaScript here. There's your password file. So that was kind of pretty big bug for this platform because we didn't have to do memory corruption. We didn't have to remotely exploit it in a sense of shellcode and that kind of stuff. We just used JavaScript to pretty much own the phone. There is, and to show you how crazy of an exploit it is, this is the source code. Doesn't it look hard? This is all it took. So once we could execute JavaScript, we had a lot of capabilities. We could even access the Mojo framework and all the other stuff that we shouldn't have been able to do.
So that was just the raw HTML source of the email.
That's it.
Yeah, and there's a distinction to make. Remember I said that there's 2 web browsers?
Yeah.
The HTML app is running in Luna because it's a native application. So it's going to render in that trusted web browser. It's not the one you browse the web with. Now, I think that the file URI handler is but yeah. The problem is that there's 2 XML HTTP requests. One that was reviewed for use from the web, one that wasn't really reviewed for use locally.
Yes. So I'm going to turn it over to him. He has a lot of some really cool local stuff that he's going to talk about now.
Great job. Okay, so I think something that all mobile phone vendors are trying to do now is if you run a local application, that application should be sandboxed in some way. So hopefully it won't be like the PC where if I run solitaire, then that solitaire application can totally own up the entire PC. We want to make it better. We want to be able to run solitaire and then not allow that solitaire application to access your email. So I'm going to talk about what happens if we write a malicious app and we get it on there, or what happens if we more likely find an injection bug in a third-party application that doesn't have access to talk to the private bus. How am I going to escalate my privileges and get access to sensitive data on the device? So really what I want to do is I want to find a way to go from my clock application to my email application. And I'm going to do this by exploiting the IPC mechanisms on the phone. So the way that different applications and the services communicate. Thankfully, there's a lot of local attack surface. And all these bugs, by the way, everything that we've talked about have been disclosed and fixed for quite some time. Anyway, when legitimately the one way that applications will communicate is that they'll use the application manager to launch other applications. So for example here, I want to launch a movie application and maybe look up movie times or something like that. And here you can see I talk to the application manager, and this is going to be the ID of the app I want to start, and then here are some parameters I'll pass to it. Okay, so there are no restrictions. Every app can launch every other app, and we have parameters, and the parameters are just JSON. And so what's the first thing you're going to do? Well, the parameters could be very malicious. They could contain JavaScript, so we could be looking to leverage other injection vulnerabilities, or they could exploit business logic issues. So the first vector is we'll actually launch another app. And this is the update application that we talked about earlier. And we'll send over JavaScript in the version parameter, right? That JavaScript is going to be what we call a Mojo stager. So it's a compact snippet of JavaScript. It's going to use the Mojo load script with callback method to refer to an external JavaScript file. That's our shellcode. And that shellcode is going to talk to the email service and basically read all the email out of the email and upload it to a remote service. So remember that email service I talked about in the very beginning is on the private bus. The email storage system, I can't send messages to it unless I'm a com.pom app. So what I did is I found a bug in a com.pom app, sent my JavaScript from my third-party application to that app, and then once my JavaScript is running, I then use those privileges to access the private bus and steal the email. Another interesting thing is WebOS applications are constructed very similarly to kind of a website. You'll have multiple scenes or basically multiple pages, and there'll be a stack of pages that you can either push or pop off of, right, to do your navigation. And so this is used in one way to give you privileges to stuff that you normally wouldn't have access to. So for example, if I want to take a picture, Palm does not allow you access to the camera control by default because they don't want you turning on the camera without the user's permission. So what you have to do is you have to push the com.pom camera application and say, take a picture for me and then give me back that data. And that's how I'm going to use the camera. So a legitimate cross-application push says, okay, push a scene from com.pom.app.camera, push the capture scene, and then pass some parameters to it. So once again, we could have parameter validation issues because the scenes could have arbitrary parameters. Some apps or some scenes don't realize or aren't written in such a way that they expect to be invoked cross-application. So say you have like, this makes more sense on the web, but you might have like a 4-stage purchase flow for a website. You put stuff in your cart, you review your cart, you do a checkout, you get confirmation. Okay, so how many bugs have been found where you skip the first 3 steps and you go straight to the confirmation page? And it didn't expect you to do that. It didn't expect you to pass bad parameters. Same problem here. You might have a multi-stage application, multi-scene application. Well, I'm not going to launch the first 2 scenes. I'm going to launch the 3rd scene. And the update bug was like this. But also another bug I found in the camera is you can pass parameters, and one of the parameters you can pass is like the file you want to write to. So we'll tell the phone to write to kernel memory when you take a picture. And obviously this isn't going to be like a remotely exploitable bug, but certainly the phone is going to reboot and blow up. And I think it's a promising area of research. So when you find a kernel exploit that you can trigger by taking a picture of something, please tell me, because that would be super cool. But anyway, so bugs like this, parameter validation bugs, are prevalent on WebOS because the documentation, frankly, is a little bit weak about how scenes can be launched and about the application lifecycle in regards to parameter validation and out-of-order invocation.
Does it actually run as is that actually a privileged process? Because normally
it's a com.pom.camera app.
It runs with essentially.
Yeah, and what it uses is it uses the NP API plugin that has access to the camera device. Right, so there's like a piece of native code that's the bridge between the JavaScript running in WebKit and the camera device to do the capture. And so that camera control has like a method that's like, here's the file name to write data to, please. And, right. Some other injection bugs that we found, I'm not going to go into too much detail. One is that sometimes you can pass JSON as a string. So you're not passing like an object, you're passing just the JSON as a string, and the remote guys are going to reevaluate that JSON to turn it back into an object, to rehydrate it from JSON to an object. And so when you pass that string, then you just pass some JavaScript that you wanted to evaluate when it rehydrates the object. And if they don't rehydrate the object using basically a special parameter, then that JavaScript will execute. Additionally, POM has basically a special HTML templating language, and that HTML templating language in the first versions of the phone didn't escape HTML or didn't escape user data when it was combined with the HTML. So guess what people didn't do? They didn't escape the data manually. Now by default it escapes data, but a lot of the legacy applications like the email, like the contacts, all the apps that were written when escaping HTML was the default, they turn off that feature. So they have to do it all manually. And so if you're reviewing code, what you want to look for is the magic minus sign that says, don't HTML escape this. One thing that we really want to point out is that we found a lot, there's basically like 3 different types of injections. You can get HTML injection. Depending on where you get the HTML injection, you might be able to launch documents or web pages without clicking. But you won't be able to execute JavaScript. Sometimes you can execute JavaScript, but you can't access Mojo. So that means that I can't do some of the cross-app launching attacks I talked about, because to do that, I need to be able to launch Mojo and basically, in order to send that message across process. And then lastly, you get Mojo, and that's, well, when you have Mojo, you have Mojo. And when you do that, then you have the ability to access all the phone services, and then that's how you're going to really jump across applications like I demonstrated. Now, I guess maybe the question would be, how do you tell the difference between the 3 bugs, or what is the protection system that makes it so in these different contexts, JavaScript or HTML doesn't work? I don't know. I'm still looking into that. I think that,
we would find areas where you could do HTML and not JavaScript. You could do JavaScript and not Mojo, and then it would just, we had to do further research in that area, but between the 2 of us, we haven't figured that out.
I actually came up with the idea that I think that some cool diffing to do might be, POM publishes their WebKit diffs. So I bet the answer lies in their WebKit diff, because that's probably how they configure the rendering to allow or disallow JavaScript. Anyway, that's my running theory. So, okay, how do you mitigate WebOS script injection? You buy a book on mitigating web attacks, and you validate input. You use, to stop the JSON, you have to pass eval JSON true. Don't forget the true. The true is very important. That's another good thing to look for when code auditing. Don't disable HTML escaping. And then, lastly, don't generate HTML using string concatenation. Use inner text, or use all the other bad web coding practices that we've talked about in the future. or in the past. I'll talk about it in the future. My thoughts, well, frankly, the phone is not doing so hot. Maybe you've seen that in the news. But I think that this serves as a really great case study in that web technologies, I'm convinced, are going to become more common in the desktop applications that we create. Because there are so many web developers out there. HTML is a pretty good presentation language. JavaScript's a pretty good language to use for manipulating stuff. So why wouldn't we be able to instantly leverage all those JavaScript and HTML developers we have? Lastly, next, I think that it's amazing what Palm has done in creating this phone. It's really cool. It's really fun. And they created it in a short amount of time. If you're going to throw a Hail Mary pass to put out technology to hopefully save your company, I would be really proud of putting this technology out. But what you probably have is a bunch of, and so you end up having them introduce some bugs that hopefully they would have avoided otherwise. Also, it's kind of funny because you have the opposite of the Objective-C problem on iPhone. You see a lot of poorly written apps on iPhone that maybe have traditional memory corruption bugs. And that's because you have a lot of web developers writing code that doesn't have a memory manager. And it's kind of funny to see the other way where you have these like hardcore devs all of a sudden writing web code and having bugs that way. So, ha ha ha. Right. And I really want to go out of my way to say that I really think that this device is really cool. It's really fun to play with. You enter the Konami code. You can totally explore it. None of the code's obfuscated. You can decompile everything using Java and get like extremely readable Java. Maybe you should read the MMS stack because you can see an MMS implementation. Those are hard to find. Anyway, so I think it's really cool.
Us never really, in dealing with them, they were very good to us.
Yeah, absolutely.
I get the sense from you guys that you're very good, you're very responsive to fixing bugs. Not everything will be the other guys go to the good
Right.
But it seems from the talk that there's no threat modeling, there's no cybersecurity that goes with it. Do you get a sense that they are getting serious about that? And if you guys think it's not threat modeling,
I can't comment on the development practice, like leading up to the creation of the device or what they're doing now. I know their security team is bigger, so that's a step in the right direction.
So the first time I
you
really,
get a sense that they're doing a lot of things.
they are, I feel like I'll say that I think they are now. Maybe they weren't, or maybe they have. I can't speak to what they did prior. But so the first bug I released to them was like a week after it launched. And then he was like, I'm the only guy, I don't even have a process for this yet. And then as things got further along, I would submit stuff and it would come back real fast. So you could definitely feel progression. That may have been just face value. Maybe it was nothing, I don't know. But I do know this, when I released the file access vulnerability, I basically said, they were like, oh, we can't replicate this. And I said, here's my website, and I could see them banging off my box. So they weren't just ignoring it and then just saying whatever. So you could kind of feel it as time went on.
Yeah, that 4141 bug, I submitted to them 2 days ago, and they say it's fixed and coming in the upcoming release. So, I don't know. They're really nice guys. Yeah, no, I think that, like, I don't know what's happening behind the scenes. Like, if the security team's growing, the guy that we talked to is there smart, I would think that they are paying more attention to that. I think that, their API documentation is also greatly improved, but I think that it perhaps needs some more security information in there because that's not really talked about. And I don't know what it is, but you have web developers developing for the phone. I don't feel like they make the leap that web vulnerabilities might be a problem here. But like I said, I think we can only judge their response, and their response has been good and improving. So, maybe that puts them into a good spot. Yeah.
How well documented is the situation where one would choose to use one web browser as opposed to the other? And that could be a source of confusion.
Well, it's actually pretty obvious because if you're going to sit down and you're going to say, I'm going to write a native WebOS application, then you're using Luna, the fancy browser, And if the only time somebody would use that other web browser is when they're actually using the web browser application and browsing a site. So it's pretty,
It's a little complicated.
I don't know how well documented it is. It just happens. Like it happens the way you would expect it.
Except when it's done.
Right.
Question, so how long is the response time on average? Like, when we contact them and they get back to you and they fix it and release, like, do you have any information on those dates or time? Just on average, not
So I think the first few bugs I released to them, so I didn't just release one bug the first time. I released like the V-card thing and a few other things. And you could tell that there was a core problem. Right? It was all the same attack. So it's the same injection. That took a little while to get the response.
Months or weeks or?
I would say it was a couple weeks the first time, almost a month, which isn't too bad considering.
It's interesting when you have that many customers, you know, that's the reason I asked, it's really fast, that's almost as bad as taking a really long time, right?
Yeah.
Checks and balances are going to be in place necessarily. It depends on that many customers, that many versions of the hardware. I'm just curious, and that might explain.
Well, I mean, they moved quickly to put this phone out there, and I mean, every change list that you look at, the phone is like rapidly improving. I think that security doesn't drive these release vehicles for them. I think that they just always have a release vehicle coming up anyway, so it's really easy to say we're going to drop a security fix into that.
I think we've driven one week.
Actually, because I mean, that kind of regulates out a lot of QA too, right? You have a week to response process, I mean.
Is that like 2 weeks, not response to them, but is that to OTA update? Or is that just their communication with you?
Yeah.
Oh, no. One thing I will say is, once I got a hold of their security person, never had a problem with it. Absolutely responsive. Some updates took longer than others. I imagine there may have been some maybe core issues that they needed to fix. But they were always responsive, and I always ping them like, where are we? I didn't let them go.
Is it an automatic update? Or
Yeah, I got so burned, dude. I had my phone on like an old patch version so I could show all these bugs, and it's on Wi-Fi at my house. I don't even have Sprint service, and I plugged it in on my Wi-Fi network, and it auto updated once it was plugged in on power and on the Wi-Fi network. So
That'll be a lot of auto carriers.
I mean, I bought my phone at Radio Shack, and I've never had service. I use stuff from WebOS internals to just use Wi-Fi. So I don't know.
Yeah, they're like, so there's a couple places, they're in Canada, they're in Mexico, and now they're a bunch in Europe. But they do the mandatory automatic update when you connect to your hotspot.
Alex?
Oh, I was actually asked about the
Okay.
how package stuff.
I didn't. We haven't looked at that.
Okay, so you talk about the initial one in the beginning when they had, you could take an email and load an IPK file.
Yeah.
Yeah. So one of the bugs that came out, I didn't find it. I did do some work with the people who did, but they did a really good job of figuring this out. You could actually load IPK files without going through POM.
IPKs are app
Yeah, they're
packages.
just the packages to install an application on the phone. And that, the minute they found out about that, it was literally like we found it on a Sunday or a Saturday, and it was patched by like Monday. You know, they really, for like a week or something like that, really fast, because that was a major problem, because you could actually execute anything at that point.
The other question is going to have, can you tell the exact version from user history?
Yes.
Yeah.
You can, well, yes.
So it'd be interesting to see if somebody has an analysis from any of those, analytics companies, what the actual all that.
One thing they do in their security reporting is they talk in very general terms about the bug, and then after the language that they say is after the majority of our users have accepted the update, then they'll change it to a more specific version of the bug, and give. I don't know. It's when they do their attribution. I don't know.
They give attribution, they don't always get the plug, right?
Yeah.
Which, that could be said for a bunch of vendors, but they do get one, they're very cool when given attribution, so.
But the point being that they switch it at a certain point after to a more detailed description after a large number of their users have deployed the update. So I don't know if that's actually driven by some fancy spreadsheet at Palm, but I do know that those bugs after a month change their description, so maybe that's a good indicator. Any questions? Well, thank you very much for your time. I thought that was excellent.